Here we're going to have a look at what happens inside a simple four-stroke internal combustion engine. So this engine here is a Briggs & Stratton single-cylinder four-stroke internal combustion engine. We have a piston over here which travels up and down inside a cylinder. The piston is connected to a crankshaft via a connecting rod. The crankshaft is connected to this arm that allows me to rotate it, so we can see what happens as the piston travels up and down inside the engine. The exhaust would be connected to this section here, so the exhaust would come out of the engine, would flow through the exhaust system. So the air that's going to burn with the fuel enters the engine through the air intake. It then passes along a venturi where fuel is sucked up and mixed with the air before it passes along to enter into the engine. So let's now have a look at the four strokes of the engine. And to make this a bit simpler, let's take the head off the engine. So remove the head of the engine so that we can see the piston and the valves. So now let's have a look at the four strokes of the engine. The first stroke has the piston travelling down. The piston travels down and the intake valve opens, so we draw the air-fuel mixture into the engine. Near the bottom of the stroke, the intake valve now closes. The intake and the exhaust valves are closed. The piston travels up and compresses the air-fuel mixture in the second stroke. At the end of the second stroke, the spark plug fires, igniting the air-fuel mixture, which drives the piston down. This is the power stroke. Both the inlet valve and the exhaust valve are closed. At the bottom of the stroke, the exhaust valve starts to open and we get the final stroke, which is the exhaust stroke, where the air-fuel mixture is expelled out through the exhaust system. And then we're ready for the next intake stroke.
The dual-fuel engine is also equipped with a backup fuel system. This is a normal diesel process with camshaft-operated liquid fuel pumps. The pumps run in parallel with the process and work as a standby. Gas and pilot injection is not in use during liquid fuel operation.
From this diagram, we are going to learn how basically an automobile engine works. This is a cylinder. This is basically one cylinder that we have, and these are the walls of the cylinder, and this is the piston that we have, and this piston is what moves up and down, and we have two inlets. One inlet is for fuel and air to come in a mixture, and this is a valve that opens and closes. And there is another outlet here that takes out the exhaust gases, and there is another valve that opens and closes at appropriate times. And when the fuel and air mixture is inside, this spark plug provides a spark to ignite the mixture. Now let's see in sequence what happens in this cylinder. This piston basically moves up and down. So the first step is to bring the fuel and oxidizer or air inside the mixture. So this valve opens up. This valve, of course, is closed, and this fuel and air mixture comes in as this piston is pushed down. This acts like a syringe, a medical syringe. When we push this down, the fuel and air mixture is basically sucked in, and it fills up this entire volume as this piston comes down. That is the first step or stroke. This is a four-stroke engine that we are talking about. First stroke is intake. And the second stroke now, the second step is we close both of these valves and push this mixture. This mixture is, again, by pushing the piston up, this mixture that is in here is compressed to very high pressures, roughly about 8 times to 9 times. and this piston moves back up here, and again we have to spend energy to move this piston up or compress this mixture here. When this mixture is compressed to the predetermined pressures, at that time the spark plug ignites this mixture, and this flame front travels all the way and burns all this fuel, and this fuel reaches very high temperatures and it pushes the piston all the way down. So this is actually the power stroke. The first stroke is intake. The second stroke is compression. And the third stroke is the power stroke. That is the stroke that gives us the power from this engine. And the first stroke and the second stroke, we have to supply the energy that is required to bring in the oxidizer and fuel, and also to compress. And after this mixture expands or pushes the piston down, this exhaust valve will open, and of course this valve is still closed, and the piston again moves back up, and for which we have to supply the power, and all these gases go out through this exhaust. And once the exhaust gases are out, this valve closes again, and this valve opens, and the entire cycle again repeats. So the fourth stroke is the exhaust stroke. So this is a basically four-stroke engine that we are talking about. We need to know the 4 strokes and the important components of this engine cylinder. And there generally will be multiple cylinders. We're talking about one here, and there could be 4, there could be 6, there could be 8, or even 10, or even 12 sometimes. So as the engine becomes bigger and bigger, you have more cylinders, and that gives us more power.
How to increase the horsepower of your 4-cylinder car. 4-cylinder engines are among the most versatile in modern vehicles, but you may be disappointed with the power they produce. Fortunately, there are a number of ways to pull more power out of the 4-cylinder motor in your car or truck. Depending on your budget and skill set, you may choose to pursue a number of options, but be aware that many of these modifications may void your warranty. Maximizing your car's performance. Properly maintain your vehicle. Although it's often overlooked as a way to pull additional horsepower from your motor, properly maintaining your vehicle is essential to producing as much power as possible. Refer to your vehicle's owner's manual for recommended service intervals and ensure you adhere to them. Make sure to change your oil every 3,000 miles or at your vehicle's recommended intervals. Replace your air and fuel filters periodically to ensure the unimpeded flow of air and fuel into the engine. Install a cold air intake. The 4-cylinder engine in your vehicle is powered by compressing a mixture of air and fuel and igniting it. Because the level of compression your engine will produce is a constant determined by the piston throw, you can produce more power by allowing for the flow of more air and fuel into the engine itself. To install a new intake, remove the stock intake tube and air box surrounding the air filter and replace it with an aftermarket one designed to increase the amount of air that passes into the engine. 2. Most aftermarket cold air intakes come with a cone-shaped filter that more efficiently pulls air from the atmosphere. Increasing the amount of airflow into your engine can also improve gas mileage. Many aftermarket intakes produce more noise than their stock counterparts. Most aftermarket cold air intakes come with a cone-shaped filter that more efficiently pulls air from the atmosphere. Increasing the amount of airflow into your engine can also improve gas mileage. Many aftermarket intakes produce more noise than their stock counterparts. Improve your vehicle's exhaust flow. As your engine ignites the mixture of air and fuel, it pushes the piston downward. The exhaust produced from this explosion must be evacuated from the cylinder chamber before more air and fuel can be injected. Replacing portions of your exhaust with larger diameter pipes will reduce the backpressure, limiting the speed the exhaust may exit the engine. You may choose to replace the piping from the catalytic converter back, referred to as a cat back exhaust, or all of the piping leading to the exhaust manifold. Kits can be purchased to replace however much of your vehicle's exhaust system you may choose. Forced induction applications like turbocharged vehicles will gain even more power from installing a higher flowing exhaust than a normally aspirated engine will. Have your vehicle's computer reprogrammed. In most modern vehicles, a computer controls a number of variables that affect how the engine runs. These computers are programmed from the factory to balance efficiency, emissions, reliability, power output and gas mileage. Reprogramming the computer to prioritize power can often free up horsepower without installing any new components. Search for companies that offer replacement computers for your specific vehicle online. You can either purchase a replacement or send yours out to be reprogrammed. Many companies sell programmers you can plug into the OBDII port of your vehicle to change the code in the computer you have. Swap out ignition components. For an engine to function properly, it needs air, fuel and a spark to ignite the mix. Old spark plugs and worn-out spark plug wires can prevent your ignition system from adequately detonating the air-fuel mixture. Your ignition components are often rated to be good for up to 100,000 miles, but replacing them with specialized aftermarket components can result in a more complete burn of air and fuel. 5. The more air and fuel your engine burns, the more power it produces. Worn-out spark plugs can even fail to ignite at all, resulting in a misfire. Larger diameter or more conductive ignition wires can reduce the time it takes for the spark to reach the mixture. The more air and fuel your engine burns, the more power it produces. Worn-out spark plugs can even fail to ignite at all, resulting in a misfire. Larger diameter or more conductive ignition wires can reduce the time it takes for the spark to reach the mixture.